Let's shift our focus over to Kat Traxler's presentation. Now, Kat has been a key contributor in cloud security for a number of years. I remember Ben Allen and myself were running one of the very early SEC 540 courses, I think back in 2017, and Kat was a facilitator at that course. And it did not take me long to figure out that Kat could have easily have been up in the front of that room teaching it herself. She's continued her journey more on the GCP side of things over the last several years and has become my go-to collaborator with all things GCP that just confuse and or bewilder me. So a really excellent resource on the GCP security side. And we're really excited to listen to your current platform as a service research, Kat. So I'll let you take it from here.
Thanks so much, Eric. See if I can get my video to work here.
Yeah, looks great. We can see and hear you just fine.
Fantastic, fantastic. Speaking of, potentially going back to the office, this talk is brought to you live from the office. So a little bit of a sneak peek there. Thanks everybody for joining me today. As Eric mentioned, my name is Kat Traxler. I head up cloud security engineering at Best Buy. Cloud security engineering to you might mean constructing infrastructure as code pipelines so you can define security into policy documents, or the building of secure environments through audible, repeatable processes. My unique brand of cloud security engineering is more interested in what good looks like in the cloud, or conversely, what bad might look like. Your policy as code needs to have opinions on what particular configuration to enforce, what might be an indicator of compromise, and how might that show up in the cloud. And that's where I come in. Over the past few years, I've developed a bit of a reputation of being somewhat of a GCP whisperer, as it were. Performing security testing, researching, investigating, and topical to today's talk, just threat modeling the hell out of countless GCP environments and permutations. I think it's important to start out with, why do we care? So I think it's important to address this because I sometimes get the vibe that why should we even be spending any time on the security posture of managed services? So the quick answer to why we care is that at some point, somebody's going to ask you, is XYZ service secure? And it's nice to have thought about that. But the more nuanced answer really is that no service comes secure, air quotes, secure out of the box. Security has been and will forever be about trade-offs. Cloud providers are balancing the goals of having these high adoption rates for their services versus more restrictive, secure by default configurations. Be leery, and you're given permission to maybe even roll your eyes if a service is touted as secure by default, or secure out of the box, where secure just can mean so many different things to so many different people. Whether or not you consider something secure is all about context. And GCP does not have the context which you will be using their services. You do, you have that context. You'll know what data is flowing through a managed service. You know how regimented your IAM structure is. You know how close to least privilege you've been able to get when assigning permissions. Let's start out by doing a quick scoping exercise. So what do I mean when I say a GCP PaaS service or a GCP managed service? It helps to think about any product from Google from the perspective of its API. Whether it's a GCP PaaS offering, a workspace app, Google Maps, Mail, Android developer tools, all of these apps, all of these services, they're all publicly available products that you can interact with by a published Google API. So as of a couple of months ago, when I pulled this quick list, we came up with 351 publicly available APIs. Now, if you want to strip down all of the Google SaaS offerings, the workspace apps, all of the things that are not specifically GCP related, we get down to 156 APIs under the Google Cloud umbrella. From that 150 GCP APIs, I'm going to subtract the APIs related to infrastructure as code, infrastructure, IaaS products, the slew of miscellaneous SaaS products that are out there. So if you just want to whittle it down to the actual PaaS offerings they have, the rough back of the napkin math puts us down to 43. 43 managed service offerings in GCP that range from Cloud Spanner to managed Redis instances, App Engine, AI Platform, Data Flow, Cloud Scheduler. And what you're going to find is that not all PaaS looks alike, but there are going to be some distinct flavors. There's what GCP calls a fully managed service. Think deployment manager, cloud build, workflows, remote execution API. These are all varieties of PaaS which merely expose an API to its end users for the purpose of executing a task in GCP, where workload execution happens in a GCP project. You won't see the infrastructure that's been created for you on behalf to support the service. These services are really the glue that enable your deployments. They enable builds, pipelines, all in this like cloud native GCP way. Then we have our lipstick on a pig variety, or the more legacy PaaS offerings from GCP. The big difference with legacy PaaS services is where the infrastructure lives. Old school PaaS in GCP are things like Cloud Composer, Dataproc, Dataflow. They're just open source Apache products with handy APIs. The old school PaaS offerings have a fairly straightforward business proposition. You take an open source product, ease the management of said open source product by automatically deploying it for you, and give the customer a suite of APIs to manage the product's configuration, where Cloud Composer is your easy button for Apache Airflow. Dataproc is the easy button for Apache Hadoop. AI Notebooks is your easy button for Jupyter Notebooks. Be aware, the default configuration which these services are deployed to your project are less than ideal. Often the underlying infrastructure, which remember you have to manage, is not compatible with best practices for compute instances or GKE clusters. These products often lag behind the security features that are going to be available, say if you were to just spin up a standalone compute instance. This issue is a whole other talk unto itself and deserves to see the light of day. But I'm not going to be spending any more remaining time today talking about the security challenges of PaaS Lite, mainly because we have just some more exciting and sinister corners of PaaS to explore. That would be your fully managed PaaS services. Google PaaS, the next generation. And you'll notice a big difference with these services right off the bat. There are no infrastructure created for them in your project. Every compute instance, every GKE cluster, every container needed to execute the service is spun up on demand in a GCP project. How does this magically work? Well, the glue that's needed from an identity perspective is the creation of P4 service accounts. And you are forgiven if you've never heard of a P4 service account. P4 is internal Google lingo for a special variety of Google managed service accounts. You'll also hear them called service agents, and I'm going to refer to them pretty often from here on out as just service agents. They're created on demand when a customer enables an API. One is created per project, and a unique distinctive service account is created for every project. So per project, per product, and you got your P4. Unlike PaaS Lite, in which their runtime identity is a customer managed service account, these fully managed PaaS offerings, these P4 service agents are often the ones executing tasks at the direction of the end user. And the only reason we know that P4 service agents even exist is that they'll have IAM role bindings in your project. Permissions for them are auto-assigned as a part of enabling an API. Enable an API, and you'll see a new role binding in your project for that service agent. Sometimes the IAM permissions assigned to service agents are fairly easy to reason about. Take Cloud DLP, for example. This is a PaaS service which will scan different data repositories in your project for sensitive information. Naturally, the Cloud DLP service agent that's executing the scan is going to need permissions to read data in PubSub, read data in buckets, read data in BigQuery, so it can identify any credit cards, PII, whatever you ask it to look for. From Google's vantage point, this is really some solid identity architecture on display. Now imagine if there was just a single Google managed service account that performed DLP scanning for all customers. Now imagine that that service account was compromised. That malicious actor would have read access to all data for all Google customers who have enabled the Google DLP API, all with a compromise of one service account. So you can see why it's been prudent to have these unique service accounts created on demand for every product, for every project. It's some just classic IAM blast radius limiting here, and I say, nice work, Google. The permissions assigned to service agents are not limited to data plane access, and they're not limited to just the ability to create other resources. Sometimes the permissions assigned to P4 service agents, they have the permissions to impersonate all of the service accounts in your project. There are a whole host of service agents whose auto-assigned project level permissions include service account impersonation. These include things like the ML service agent, the AI platform notebook service agent, the cloud function service agent, cloud run, cloud scheduler, cloud task, data flow, data proc. The list goes on and on. Each one of these services has some piece of functionality that has led it to having the blanket permission to impersonate other service accounts in your project. If we can take, Cloud Scheduler just as one example. Cloud Scheduler is nothing more than a managed cron service. Built into the product is the ability to, on a schedule, make an HTTP request to an arbitrary endpoint. Most importantly, you can tell Cloud Scheduler to authenticate to the HTTP endpoint as one of your service accounts. How does this happen? Since Cloud Scheduler Service Agent has a project level impersonation permissions, it can generate an access token for whichever customer managed service account that you tell it to authenticate as. So it has the ability to generate the access token for that service account and submit it to the HTTP endpoint. So I've established that service agents can have really juicy permissions. Now, what would it look like to have the access token compromised for one of these P4 service agents? In the cloud, and especially with Google, all roads lead through the metadata API. The technique that I've recorded here was first showcased at B-Side San Francisco in 2020 by Dylan Aray and Allison Donovan. The demo here showcases the hijacking of an access token for the cloud build service account during the build process. Let's take a look at how this is done. All right, so there's a default cloud build service account. This account is automatically enabled when you enable the cloud build API. And it has a whole host of permissions that it's auto-assigned. So it has access to source repos, it has access to pub subs, has access to artifact registry out of the box. In addition, you can enable additional permissions to the cloud service, to the cloud build service account. All right, that's my service account there. So here's what we're going to do. We need access to this service account. Here I have a cloud build specification, and as part of the build process, we're going to have a few steps of the build process, which I'm going to query the internal metadata API of the container that's performing the build. And I'm going to pull out the email address and the access token for the service account and submit it to an NGRAC endpoint I stood up. You could submit this to a function. You could submit this to a Cloud Run endpoint, any listener that you have open. Let's switch over to my trigger I have set up on Cloud Build. Again, I just have a trigger set up so that whenever I push to my GitHub repo, a Cloud Build trigger is going to kick off. It's going to kick off a new build. Pretty basic stuff. And we're going to push this code to my GitHub repo as soon as I remember how to do that. All right, let's take a look at my builds. A lot of failed builds here. Have no fear. There's no intention of having a successful build. My only intention here is to have the build container process my steps so that I can exfiltrate the token from the metadata endpoint. If I switch over to NGRAC, I can see that I've already received the access token from the metadata endpoint, and it's always nice to validate that it's the correct one. See here, yep, and it's for my cloud build service agent. Just as a recap, the cloud build service account, when you enable the API, it will have access to PubSub, it will have access to sources, it'll have access to Artifactory. There's like 4 or 5 resources that it will have access to out of the box. But remember, if you want Cloud Build to deploy anything for you, if you want Cloud Build to deploy functions, to deploy compute instances for you, to deploy GKE containers, you're going to have to go ahead and enable those additional permissions. And when you enable those additional permissions, you're also going to have to provide the Cloud Build service account the act as permission, as the act as permission is required to deploy that. So as you can see here, the Cloud Build service agent or Cloud Build service account will become overprivileged very quickly. So yeah, I hope you all enjoyed that quick demo. It's just a really quick down and dirty demo for how to capture some access tokens in the build process. The specific implementation of this technique, it's going to vary from service to service, but the fundamentals, they hold true. Just query the metadata API during execution and exfiltrate the response. Legacy PaaS would certainly be vulnerable to this same class of attacks. There's nothing unique about your fully managed PaaS services. The difference, though, is that the runtime service accounts for legacy PaaS services, they will have customer managed service accounts. The theory goes that since you have control over the customer managed service accounts, you've implemented least privilege with these service accounts, or at least better than Google has with their service agents. And you've taken into account that the privilege escalation paths with customer managed service accounts, you've given them permissions at the lowest resource level possible. And you've been especially careful not to assign any permissions to your customer managed service accounts, allowing them to have the ability to impersonate other service accounts. So how could the compromise of a service agent impact Google's infrastructure? If they've designed their tenant projects correctly, there should be zero impact to Google resources should a service agent access token be accessible to a customer. It's a fairly easy assumption to make that a service agent will just never have permissions outside of these single tenanted Google managed projects that are spun up and down as APIs are enabled by their customers. Certainly, the service agents would have no IAM roles, which would allow an attacker to then pivot further into GCP infrastructure. This is why I call service agents sacrificial lambs. If their access tokens get compromised, there's just no impact to Google infrastructure. But what about their customers? What's the impact to a customer and their resources in the project should a service agent be compromised? Well, we've already established that service agents tend to be gold mines of privilege. Google assigns project level roles for service agents just to cover all their bases. As an attacker, broad project level permissions are exactly what I'm after. Compromising a service agent, or really honestly any service account with impersonation or act as permissions, that enables an attacker to pivot to other service accounts, gain control over other resources, and or pivot to other projects. So how could Google redesign their PaaS architecture to limit the risks of service account compromise? Suggestion one, if you're listening. If a service agent really needs to impersonate a customer managed service account, if they really need this, reduce the blast radius. GCP should be following their own advice and applying permissions at the resource level, especially with service account impersonation. Impersonation permissions should always be bound at the service account level, not the project level. Ensure service agents do not execute customer code. Incorporate externally controlled values into their processes, or could be elicited to make network requests. And a second suggestion, or really more of a hot take on my part, stop treating access tokens as if they have no value to an attacker. Yes, they are short-lived. They will expire anywhere between an hour and 12 hours. But a lot of damage can be done in an hour. And more importantly, the attack scenarios involving the metadata API, malicious actors typically have persistent access and would be able to query for a new access token whenever one's expires. So relying on access token expiration to thwart an attack chain is just a fool's errand. I'm going to be a little short on action items today because most of the problems with privilege escalation via service agent compromise, this is mostly in Google's court. The only actionable advice I can give you folks is to test your PaaS services before using them. If you identify a mechanism for obtaining a service agent access token, report it to Google as a vulnerability. Let's start a chorus of customers who say this is not an acceptable path for privilege escalation, even if it's considered working as intended. Some of you might be tempted to de-scope permissions assigned to service agents, as this would be your classic IAM blast radius reduction strategy. While you technically could do this, you could remove the auto-assigned service agent roles to your P4 service accounts. Your services will probably break. And when you open up a support ticket, the first thing that they will have you do is to restore the service agent role to its former massively overly privileged glory. And Google specifically warns you against modifying any of these auto-assigned service agent roles. Oh, I'm not doing bad on time. Excellent. Okay. So what did we learn today? First off, your legacy PaaS services and the fully managed PaaS services have different attack services. Second, Google is not necessarily looking out for how its customers can reduce their risk when using their services. That would be your job. Finally, I hope you all agree that we should be testing PaaS services before flipping them on, deconstructing them, understanding how they're glued together. In the context of GCP PaaS, you can start by asking yourself a few basic questions. Where does the infrastructure live? You can ask yourself what permissions are required to operate the service. Is there an associated service agent, and is it uncomfortably privileged? And finally, is there any risk of an attacker obtaining the service agent's access token? I recognize that I took everybody just head first into the deep end of the GCP pool today. And there are a lot of GCP IAM fundamentals I didn't cover. But the good news is that all of these pieces I glossed over, I have covered in previous talks, or I've covered most of them in a blog series I put out last year covering GCP IAM 101. There's some other fantastic talks and articles from researchers in this space that I really, really suggest you check out. If anybody wants like a really good, just like start here article, I think Chris Moberly wrote just the best one I can imagine. His tutorial on privilege escalation and post-exploitation tactics on the Google Cloud Platform, published February 2020. Also, Spencer put out a quintessentially Spencer post just documenting all of the GCP IAM permissions which could lead to privilege escalation. He's one of the people who got me so excited about the possibilities for privilege escalation in the cloud, and the community just tremendously misses him. I'm going to make a note of all of the resources on this slide, as I have on every talk. The oldest published material on this slide is February 2020. I know a lot has happened since February 2020, but that's not even 18 months ago. So the age of public GCP security research is still so young. I hope that's encouragement to some of you to get your hands dirty in GCP security, start contributing to a small but growing body of research, and help to add to the knowledge base. We need you here. Thank you so much for your time. I think I might have maybe 1 minute for a question. Otherwise, I'll be in the hallway.
Excellent. Awesome, Kat. That was a lot of fun to kind of walk through and see that path. We got a really quick question as you committed that malicious YAML file right out of the gate.
Yeah.
And Cornell was asking, okay, so that's the metadata service. Which version was it? And are there any mitigations if you use, the most recent version versus an older version over on the GCP side?
No, I mean, that's the latest version of the metadata API on the GCP side. There wouldn't be any mitigations for cloud build because you can tack on the appropriate headers in your curl requests. Some of the mitigations available in GCP would, protect you from SSRF, from the application side. But in this, you're able to, specify and have, the header pass through on your curl request. So, so there wouldn't be any mitigations. Vulnerable by design.
Yeah, I was thinking the same thing. It kind of highlights the importance of, pull request reviews and some of those things on public repos. If your pipeline YAML files in there and you know that a deployment's going to auto trigger that job like you just did, you've got to be really careful with the code that you let people put in there. So it's kind of an interesting attack path that way. My second question here, we've got another minute or two, I think. So, I kind of thought through your, security in GCP 101 is like use an organization with all these projects, isolating resources. That's kind of what they push you towards. I hadn't really thought of binding these service accounts at the resource level, which is really interesting for one of your takeaways. I know we've started to see them do that, with like a cloud KMS key, for example, where you can bind at the resource level. How likely do you think they would be, or how difficult would it be for them to overhaul that system and put those service accounts down at the resource level?
I can't imagine, what the undertaking would look like. I mean, I think most of the assumptions that are baked in right now are that, a PaaS offering, if they need to have that impersonation capability, just has it at the project level, sort of like no matter what service account is that you need, it's just there. So it would be like a, service by service reworking of all of how it all works. I think there is one service that I recently ran into, data flow, that does impersonate data proc at the resource level, but that's the only one I've run into. Everything else has been project level, and that's the assumption going forward. How hard it would be, I mean, I don't want to scope for them, right? I can't imagine it's going to be easy.
Yeah, it's cool to see one. So maybe we'll start to see that slowly kind of trickle out throughout the ecosystem. Lots of good comments going on in the hallway channel at this point. So I'll let you off the hook. Thank you so much, Kat, for joining us, and we'll see you out in the Slack channel.